Don, how's it going, bud?
Charlie, what's up?
How's the department?
Pretty good, except Kim has been a little bit moody lately. I hate Dawn!
That's weird, because she's been really nice to me lately. Look what I got.
It's a book. Yeah.
Yeah, it's one of Isaac Newton's long-lost journals, actually. I have no idea what he talks about in here. Calculus, tomatoes, transmissions. Yeah, but I'm really interested to find out. Hopefully I'll be able to decipher what he said. Do you hear the water running?
No, I just fixed the sink.
That's weird. What about the squirrels?
Squirrels! Every night I wake up, I think there's like an intruder in here or something.
Yeah.
But I swear it's fine, it happens all the time. Why don't we just put the book back here, like just out of our line of vision, where it's perfectly safe? I'm sure.
Alright. Well,
we could just keep talking about it, like...
Oh, I have notes on the case you gave me. The one about the spaghetti!
Well, I'll go let you look at that book if you want. I'll be right back.
Alright, see you, Don. Yeah, you know what? I think I'm gonna go to Deli and look at that. Wait a minute! This isn't a notebook! Get off my Hey, Jim! What is this even saying? I can barely read it. Wait a second. This is calculus.
Charlie, slow down!
I'm not even driving!
Not like that, like the letter. We have to slow down and figure out what the letter says.
Alright, so there's a lot of calculus on here. I see derivatives, integrals, a bunch of slope problems. I don't want to play basketball. No, Kim!
Alright.
God, I hate your girlfriend. Anyway.
Alright, so
there's a lot of stuff about slope and finding instantaneous position because this guy's crafty. He wants us to try and find out where he is and ransom the journal.
It's a ransom note.
Yes.
Listen, we're cops. We got this. This is not part of the force.
Okay.
We got this on our own. Now drive.
What are we doing here, Charlie?
Well, you saw how I used implicit differentiation to solve for the XY coordinates in that problem that Calculus Boy gave us. That led us here, to this parking lot.
Now, who's Calculus Boy?
Come on, Don, you named him that!
I thought I was Kim.
Kim! Alright, so Calculus Boy clearly had some trouble deciding what kind of equation he was going to give us. But he decided to give us a little key too. He said that X is in yards and Y is in miles, but treat them equally. So I just kind of ignored that, and he gave us two constants. Y prime is 36 and X is 2000. So when I isolated Y, that gave us a value of 4.3. When you take that back to the original information we were given, it means that the coordinates for where he is 2,000 yards away in the X coordinate and 4.3 miles away in the Y coordinate. And that's that.
But how did you know to come in this direction?
Plot points, Kim. Plot points. Oh, how did you figure out what direction it's in? I don't know, Kim. I'm a genius. That's how these shows work.
Well, look who decided to finally show up.
Calculus Boy?
Yeah, alright. Anyways, I think I have something that you want.
Yes.
And I think you have something that I want.
What is that?
Well, I need someone to pay for my college tuition, and I think you can do it.
College tuition? Where are you going?
I'm going to Harvey Mudd. It's a small liberal arts school in California.
Never heard of it.
It's not that bad. It's like 70 grand a year.
You think I have that kind of money? No way!
You're like an adult. I thought you...
That's not how it works, buddy.
Alright, well, in that case, I'll give you 3 clues as to where the book is in exchange for a bag of muscle milk.
I have some muscle milk in my pocket.
Thanks, Kim. Alright, job well done. Now, why muscle milk?
Well, I don't have a gym membership, and I gotta get big with something, you know, well, It might help. Anyways,
Adapted.
yeah, as promised, it's clues. I'll see you later, buddy.
Better run before I arrest you. Alright, so he gave me a key which says x equals 8 over 3. So I'm guessing what I have to do is solve the derivatives first and then input 8 over 3 for x. Right, so negative 3 times negative 2x squared is 6x squared plus that's 15x minus 3. So then you have 12x plus 15, and if you input 8 over 3 for that, that's 96 over 3 plus 15, which is what? 32 plus 15, which is 47. All right, number 2. This is a product rule, so that means I need to multiply f prime times g, and then add that to g prime times f. So we take 3 times 3x plus 1 plus 3 times 3x minus 1. Perfect. So that's 9x plus 3 plus 9x minus 3. So that's just 18x. And then when you input 8 over 3, that's 80 and 64, which is 144 over 3, which equals 48? Yes. This is so annoying. I'm drawing a blank. I can't even remember how to derive this.
Thought you were good at math. You're forgetting the chain rule. Derivative of the outside, normal inside, derivative of the inside.
That's it. Wait, what, Kim?
What's for dinner?
Okay, so like Kim said, we take the chain rule. So we take the derivative of the first part, so 2 times 3x plus 1, times the derivative of the inside, which is 3, minus the derivative of that last term is 1. So we have 6x plus 2 times 3 minus 1, which simplifies to 18x plus 6 minus 1, or 18x plus 5, which when you input 8 over 3, it's 144 over 3 again, so 48 plus 5 is 53. We have 3 numbers, 47, 48, and 53. What could they mean?
That's a hexadecimal code, if I've ever seen one.
Wait, so Kim's actually got a point. If it's hexadecimal, then the numbers 47, 48, and 53. GHS!
Guys? Hello? Charlie? Kim?
Morning, Don.
Kim, where's everyone?
I slept great last night. Don't you?
Are you alright? GHS?
Yeah, it's comfortable in there.
Alright, where could calculus boy be? What? Kim?
What's up, Charlie?
What are you doing here?
47, 48, 53, hexadecimal code, GHS. That's your duty.
Alright, thanks Kim, but we gotta find out where calculus boy is.
I don't speak your brain language, but I know one thing. There's a note over there.
Where? What does it say?
What have we got here?
Looks like another clue from calculus boy.
Wait, dude, why are you making me say this? Alright, that was, the hexadecimal was all a silly ploy to have you come to GHS. My velocity is given by the equation x to the third plus 5x minus 14. So try and find out where I'm going and how far I've gone before it's too late, dude.
I'm still trying to make sense of this.
This is obvious. It's a velocity time graph, so you take the integral over the period given, or however long he was traveling. You'll get the total distance traveled. We have the direction. You take that distance and apply it in that direction, and that's where the next clue is.
Good point,
Sounds
Kim.
pretty good to me.
Let's hit the road. Everybody in position. All right, so the muscle milk's here. I don't see calculus boy.
Calculus boy. It's me. Hey, Donnie. How did you guys solve that problem so quickly?
Kim got it.
Kim?
Kim? Yeah, she's pretty good at calc. Right, Kim?
All right.
You solved your problem, now where's our book?
Huh. You know, maybe you guys aren't so bad after all. Any of you guys got an iPhone?
Yeah, I got one.
I got your number already. Anyways, I'm gonna send you a problem real soon. It's a problem I dreamt up last night. It's about a funnel.
Alright.
It's not that bad. If you can solve this problem, you'll get your book back.
And if not?
If not, you'll never see it again.
Better get running, boy.
My muscle milk back. That's stupid.
I'm so hungry!
Less moral culpability is true with drugs. And he was caught in the act.
Already?
What
got there?
Oh, this is the problem that calculus boy dreamt up last night.
Looks like a doozy. Even Kim don't know how to do that.
Alright, so the inside of the funnel is 10 inches tall and has circular cross sections at height h. Radius of the funnel is given by r equals 1 over 20 times 3 plus h squared. Now I need to find the average value of the radius of the funnel.
In 2009,
Average value theorem. So that means I need to integrate it, but multiply that integral by 1 over b minus a, right? Yes. 1 over b minus a times the integral from a to b of f of x. So when we put in 1 over 10 times the integral from 0 to 10 of 1 over 20 times 3 plus h squared. Let me run a few numbers. Alright, that comes out to 1 over 200 times 30 plus 1,000 over 3 inches. Definitely got that wrong in the test. Alright, B, find the volume of the funnel. So, given the fact that the area of a cross section is pi r squared, that means we do pi times the radius that we just solved for, the h squared. Run a couple more, and that means it's pi over 400 times 9 plus 6h squared plus h to the fourth, because we're squaring a squared term, so that gives us the fourth power. Now to find the actual volume, you need to multiply that by the integral. So we put all that together, that's going to bring us to pi over 400, and you input the values 0 to 10, so that's going to be a 90 and then a 0, so 90 plus 2,000 plus 10 to the 5th, because it's h to the 4th, that's 10 to the 4th. That happens because you're integrating it, over 5 inches cubed, or 2,209 pi over 40 cubic inches. And then for C, the funnel contains liquid that is draining from the bottom. I don't know how to solve this.
Let me help you out. Looks like related rates to me.
Wait a second. Thanks, Kim. Alright, so that means h is 3 at that point, and the derivative of that, which is the rate at which it's flowing out, is negative 1/5 inches per second. So you find the derivative of that. So the derivative is equal to 1 over 20 times 2h, and that brings you to negative 1/5 is set equal to 3 over 10ths of dy over dx. So that means when you convert it dh over dt, that becomes negative 2/3 inches per second. Your move, calculus boy. That's that. I wonder where calculus boy is so we can have him check our answers.
Charlie X.
Calculus boy.
And Agent Kim Hall.
Or Kim. You solved my problem?
Yeah, looks like it.
We'll take a look.
Hand him over, Kim.
You got them all right. Good job.
Awesome. Now where's the book?
Well, it's right behind you, Kim.
I got it.
Well, I mean, it's kind of fun, even though it's a little illegal per se.
We could have arrested you.
You could have. It was pretty cool. Maybe you want to hang out sometime.
Alright, I mean, where would you want to go? Like Arby's, Chili's, Ruby Tuesdays?
Chuck E. Cheese. Yeah, I mean, any of those places is fine. So I'm thinking, maybe one.